Nearly every planet in our solar system, except for two, has its own natural satellites. While Earth's moon is the most familiar to us, its barren surface marked by ancient volcanoes and countless craters, it's just one of many moons with fascinating stories to tell. In the distant reaches of our solar system, the giant planets are surrounded by an array of moons. Many of these moons formed alongside their host planets from the same icy materials. Despite their great distance from the sun, where sunlight is scarce and temperatures are frigid, these moons are as diverse and dynamic as the planets they orbit. Enceladus. Since Cassini arrived at Saturn in 2004, Enceladus has become a major focus due to its massive water ice plumes erupting from its southern hemisphere, revealing liquid water beneath its icy crust. Though just 313 miles, 504 kilometers in diameter, Enceladus should have frozen long ago. However, tidal forces from Saturn and its moon Dione keep its interior warm and active, making it a prime target in the search for extraterrestrial life. The ice erupts and mostly falls back, but some escapes, forming the E ring, Saturn's faintest and outermost major ring. Callisto, Jupiter's outermost Galilean moon, is the third largest moon in the solar system, just smaller than Mercury. It is the most heavily cratered body known, with its dark surface covered in craters. The deepest craters have exposed fresh ice beneath, scattering bright debris. Callisto's cratered look is due to its location within Jupiter's strong gravitational field, which disrupts comet orbits and draws them in, as seen in the 1994 comet Shoemaker-Levy 9 impact. While Jupiter's larger moons endure frequent impacts and geological changes, Callisto's surface has remained largely intact for over 4.5 billion years, preserving its ancient craters. Dactyl. Minor planet 243 Ida has a small moon, Dactyl, just 0.99 miles, 1.6 kilometers in diameter. Given Ida's weak gravity, it's unlikely Dactyl was captured. Instead, they may have formed together. Ida is part of the Coronis family, a group of over 300 asteroids formed 1 to 2 billion years ago from a massive collision, while Dactyl could be a fragment from this event. Models suggest it should have been destroyed by asteroid impacts long ago. Dactyl's longevity might be explained by a younger Coronis family, or by Dactyl surviving and reforming after a disruptive impact, as observed by NASA, giving it its current shape. Iapetus is one of the solar system's most peculiar moons, notable for its striking color contrast. Observed in 1671, its leading hemisphere is dark brown, while the trailing side is light gray. Early theories suggested this was due to dust from outer moons settling on the leading side. Cassini's recent images reveal a more complex story. The dark material likely comes from within Iapetus itself. Sublimation of dust-laden ice leaves a dark residue, with the process accelerating as the surface absorbs heat. Additionally, Iapetus features a unique equatorial ridge, rising 8 miles, 13 kilometers, and stretching 12 miles, 20 kilometers wide, giving it a walnut shape. Its origin is debated, with theories suggesting it could be from a faster spin in the past or debris from a collapsed ring system. Nereid, the second moon discovered orbiting Neptune, is notable for its highly eccentric orbit. The distance between Nereid and Neptune varies dramatically, ranging from 870,000 to 6 million miles, 1.4 million to 9.7 million kilometers. Such an orbit is typically seen in captured satellites, asteroids, and comets drawn into irregular paths by the gravity of the outer planets. However, Nereid's substantial size hints at a more intriguing scenario. Voyager 2's 1989 flyby provided evidence suggesting that Neptune's largest moon, Triton, was originally captured from the nearby Kuiper Belt. This capture would have disturbed the orbits of Neptune's original moons, likely causing many to be ejected. Some astronomers speculate that Nereid might be one of the few survivors, remaining at the fringes of Neptune's gravitational influence. Io, the innermost of Jupiter's 4 Galilean moons, stands out with its vibrant landscape of yellows, reds, and browns, marked by intense volcanic activity. Unlike the outer 3 moons, which are relatively calm, Io is the most volcanic body in the solar system. Its unique surface, first noted by Pioneer space probes in the 1970s, was confirmed as volcanic just before Voyager 1's arrival in 1979. Io's eccentric orbit, influenced by gravitational forces from Jupiter and its neighboring moons, causes significant tidal stress. These forces generate immense friction, keeping Io's interior molten and fueling vast magma reservoirs beneath the surface. Though Io's rocks are similar to Earth's silicates, they are mostly molten in a hot magma ocean below the surface. The majority of its surface activity involves sulfur-rich materials that remain liquid at lower temperatures. This volcanic activity has stripped Io of any icy material, resulting in a dry, iceless world with an average temperature of minus 256 degrees Fahrenheit, minus 160 degrees Celsius. Hyperion. Hyperion is the most unusual moon in the solar system, with a surface resembling a sponge or coral, marked by deep pits and sharp ridges of rock and ice. It was the first discovered non-spherical moon and has a highly eccentric orbit. Unlike most moons, Hyperion doesn't rotate in sync with its orbit. Instead, it spins erratically with a wobbling axis. Composed mostly of water ice, Hyperion's dark surface and low density, 55% that of water, indicate its interior is largely hollow. One theory suggests Hyperion is a remnant of a larger moon that once orbited between Titan and Iapetus, destroyed by a comet collision. The surviving debris then reassembled to form Hyperion. Titan. Saturn's largest moon stands out as the only moon in the solar system with a significant atmosphere. Early Voyager images showed it as a hazy orange ball, frustrating scientists. However, Cassini's infrared and radar instruments revealed a landscape of rivers and lakes, similar to Earth, beneath its thick, opaque atmosphere. Titan, larger than Mercury, retains its atmosphere due to its extreme cold, with average surface temperatures around minus 290 degrees Fahrenheit, minus 179 degrees Celsius. Titan's atmosphere is mostly nitrogen, with a small amount of methane giving it its haze and color. This methane undergoes a cycle akin to Earth's water cycle, shifting between gas, liquid, and solid forms. Methane freezes as frost, condenses into rain, and evaporates, shaping the landscape and creating lakes. Titan experiences seasons similar to Earth's, with a 29.5-year orbit. Seasonal changes cause lakes to migrate between poles. Despite its intriguing features, the harsh conditions on Titan make it less likely to harbor life compared to its moon, Enceladus. Miranda. Miranda is one of the most unusual moons in the solar system, with a bizarre patchwork surface revealed by Voyager images. Its terrain varies from heavily cratered to relatively smooth, with notable features like concentric ovals and parallel V-shaped scars. Initially, some thought Miranda was a Frankenstein moon, formed from debris of a shattered predecessor, possibly linked to Uranus' extreme tilt. However, this theory fails to fully explain Miranda's diverse surface features. It's now believed that tidal forces are responsible. Miranda's past orbit was in resonance with the larger moon Umbriel, causing frequent alignments that stretched its orbit into an elongated ellipse. These tidal forces heated and fractured Miranda's surface, creating its jumbled appearance before its orbit settled into a nearly circular path.